in math, and in general life, to be honest, there are times where in order to know something, there's something else that we need to know. So if we know this one thing, then we can use that to work out a second thing. If we didn't know that first thing, we couldn't work out what the second thing was. But because we know this first thing, we know what the second thing is. Well, that situation I've just described is described more completely in math using something called a function. We use one thing to work out what another thing is. Firstly, we have a concept related to the function called a relation. So a relation is a collection of ordered pairs. Now, I'm wanting to be precise with our language here. Ordered pairs are the things that we use as coordinates often when we're doing a graph, but it groups two variables together. In fact, it represents a relationship between two variables. That really just says there is a connection between what the two variables are. Now we're looking at a particular type of relation, which I've already said the name of. It's called a function. But the function works like this. There is one variable, which we're going to call the independent variable. And that determines the value of the other variable, which we're going to call the dependent variable. Now, in practice, we often call this first variable x and the second one y. But these are the two things I was talking about earlier. X is the first thing that we already know, and y is the thing that we can work out if we know what x is. Now, another way we can describe these as an input and an output. And we can say that each input of the function produces exactly one output. If we know what x is, we know exactly what y is. Now, two ways we can represent functions are using algebraic rules and with tables. Now, let's kind of start getting our minds around the idea of the way a function works. These are called function machines. They're imaginary machines. They don't actually exist. But imagine a function is a box which takes some kind of input into it and it spits out some kind of output. So for each of these, we've stated what the input is. For this first machine, it's x equals 6. And then the machine tells us that we work out what y is by multiplying x by 7. Well, if we multiply our input by 7, we get 42. So that's our output. For the next machine, the rule on the machine tells us that y is x take 9. For the input of x equals 4, we have 4 take 9, which is negative 5. So y equals negative 5. For this machine, where y is x divided by 12, so the output is the input divided by 12, our input is x equals negative 3. Negative 3 divided by 12 simplifies to negative 1/4. So that's our output. Now, usually, with the types of functions we're going to look at, they're going to be sort of like the ones that we've written up here using our standard for mathematical operations. But we can use more complicated operations as well. So we can square things. If we square negative 5, we get y equals 25. We can have a number to the power of our input. So if we got 3 to the power of x, and x, our input, is negative 2, 3 to the power of negative 2 is 1/9. So our output is 1/9. We could even have the square root of our input. So the input here is 121. the square root of that input is our output, which is 11. Now, usually when we have a function, we don't just work out one value, but we work out a bunch of values using that function. So here we have a function with the rule y equals 2x plus 5. And we have these different inputs. So we're going to work out the output for each input. So the first one is x equals 3. That means, using substitution, y equals 2 times 3 plus 5. 2 times 3 is 6, and then 6 plus 5 is 11. So that is our output. For the next input, x equals negative 6. So y is equal to 2 times negative 6 plus 5. 2 times negative 6 is negative 12. And negative 12 plus 5 is negative 7. Then we have x equals 7.5. So y equals 2 times 7.5 plus 5. 2 times 7.5 is 15. And 15 plus 5 is 20. We're going to do this again for another function. This one's more complicated because it has a squared in it. Now, for most of the work we do with functions, we're not going to deal with ones with powers or exponents or anything else. But we can still use the same idea because we know how to evaluate expressions with powers. So let's do that. So for the input y equals 1, y is equal to 1 squared, take 9. 1 squared is 1, and 1 take 8 is negative 7. For the input x equals negative 3, y is equal to negative 3 squared, take 9. Negative 3 squared is 9, so this is 9 take 9, which is 0. And if the input is 4.5, then y is equal to 4.5 squared, take 9. 4.5 squared, which would be 4.5 times 4.5. So that would be 20.25, take 9, which is equal to 11.25. Now, as I said, we're not really going to work with functions with powers in them, at least not this year. But the idea isn't actually that much more complicated. Now, once we have a function with a rule, we can take that rule and turn it into a table. So this is simply where we have 2 rows, one for inputs and one for outputs. Sometimes you see these written the other way, where we have 2 columns instead, with a column for inputs and a column for outputs. But these examples are using rows. So the function here is y equals 4x take 11. So that means we're going to take our input, multiply it by 4, and then subtract 11 to get our output. So 4 times negative 3 would be negative 12. And take 11 is negative 23. 4 times negative 2 would be negative 8. Take 11, which is negative 19. And we can go through and work out what each of these are. And the table eventually is filled out. Let's double check this last one, make sure we got it right. 4 times 5 is 20, take 11 is 9. Let's look at our next example. So y equals negative 3 times our input plus 5. So negative 3 times negative 6 would be 18, plus 5 is 23. Negative 3 times negative 4 is 12, plus 5 is 17. Negative 3 times negative 3 is 9, plus 5 is 14. And then we can go through and and figure out the rest of these. Finally, if we do negative 3 times 10, that's negative 30, plus 5 is negative 25. Okay, for our last function, we have y equals x to the power of 3. That means we take our input and we have it to the power of 3. Now don't forget, what that really means is you multiply it by itself 3 times. So for our first input, that is negative 4 times negative 4 times negative 4, which works out to be negative 64. Negative 3 to the power of 3 is negative 27. Negative 2 to the power of 3 is negative 8. And we can go through and evaluate our table for the rest of these inputs. Like so.